Welcome back from the ad break, and let's continue with our lesson. So now we are going to go into more of the application questions. Let's look at the first one there. It says there, simplify the following questions without the use of a calculator. Let's look at our first question there. Now we are dividing powers, and when we look at these powers, they have the same base. Now that applies to our second exponent law. And do you remember what we do when we are dividing powers of the same base? Yes, you are correct. We are going to subtract those exponents. So it's going to be exponent 3 minus exponent 2. And that is going to leave us with a final answer of a base 7 and an exponent 1. And of course, we know that if there's an exponent 1, then it is just the same as a 7. Let's look at the next one here. So when we look at the next two powers that are being multiplied, they're still powers because there is a base and an exponent, but now we are working with variables. So does that mean that the same laws still apply? Yes, the same laws definitely still apply. So we are multiplying. Now, do you remember what we do when we are multiplying powers of the same base? Now we look at these two powers. Do they have the same base? Yes, they do. We have a base x with the first power and a base x with the second power. So what does this mean? This means that we are going to keep that base. And what happens to the exponents because we are multiplying? Yes, we are going to add those exponents. So that is going to be a 3 plus a 5. That is going to give us an answer of a base x and an exponent 8. And that is going to be our final answer. Let's go over to the next questions. We are still simplifying without the use of a calculator. Now we have a exponent 4 multiplied by a exponent 5. Now take note how they have the same base and we are multiplying. So what does this mean for the exponents? Yes, it means that we are going to add those exponents. So we are going to have there a 4 plus a 5. So this is going to give us a final answer of, yes, a exponent 9. And where does that 9 come from? It comes from us adding those two exponents, 4 plus 5. And remember, we only added because we are multiplying powers that have the same base. Number 4 there is m exponent 5 divided by m. Now, how are we going to solve for this? Firstly, we are dividing powers, and these powers have the same base. So what does that mean for the exponents? We are going to subtract the exponents. But look at the first power there. We can see that the exponent is a 5. What about that second power there? What is the exponent there? Yes, it is a 1. You are correct. So now that we've seen each of the exponents in each of the powers, then we can go ahead and simplify this expression. So we are going to say there that it's going to be m, and in the exponents we are going to subtract 5 minus 1. So we are going to subtract the 1 from the 5. So this is going to give us an answer of m exponent 4. Why? Because 5 minus 1 is 4. Now, looking at the next example, number 5 here has more than one variable there. So we are going to work at it the same way that we've been working with the other expressions there. So we have a exponent 5 and b exponent 3 divided by a exponent 2 multiplied by b. Now, firstly, we know that that b has an exponent 1 as explained previously, that if there's no exponent there, then the exponent is a 1. Then we are going to divide. Now remember, when it comes to division of powers of the same base, you need to make sure that you are looking at powers that have the same base. So now we are going to be looking at the a exponent 5 with the a exponent 2. So how are we going to work at this. Now, looking at the a's, this is going to be a, and it's going to be a 5 minus a 2. Why are we choosing the exponent 5 and the exponent 2? Because they have the same base. Then we also have the b, and that is going to have as an exponent a 3 minus 1. So we took the exponent from this power of that has a base b, and we took the exponent from this power that has a base b. So what is my final answer going to look like? Yes, if you have the a exponent 3, then you are correct, but that's not it. We also multiply that with a b exponent 2, and that is going to be our final answer there. Now, why are we not adding these two exponents here? Because we are multiplying. So why are we not adding these two exponents there? Yes, because the powers do not have the same base. So if they don't have the same base, we cannot add the exponents. So even though it is multiplication, but we cannot add the exponents because the bases are not the same. Let's look at this next question here. So we have k exponent 4 multiplied by k exponent 3 multiplied by x squared, and this is multiplied by k x exponent 5. So what do? We need to ensure that the exponents that we are going to add have the same base. And why are we adding? Because we are multiplying. So let's start off with the base k. So when we look at k, we can see that this first power has an exponent of 4. We are going to add this with the exponent of 3 that we find there, and then we are going to add this with the exponent of 1. Now, where does that 1 come from? Look at this expression here. Now, this expression here has k x exponent 5. Now, that k definitely has an exponent 1 there. Let us not forget that. So we have an exponent 1 there by that k. That is why we are saying there it's the 4 plus the 3 plus that 1 over there. And then we are going to multiply this by x because we cannot forget that x there. And when we are looking at our base x's there, we have an exponent 2, and we are going to add this with an exponent 5. Now, that k there, we are going to say 4 plus 3 plus 1. That gives us an 8. And of course, we have an x there, which is a 2 plus 5, that will give us a 7. And that will be our final answer. K exponent 8 multiplied by x exponent 7. And again, we will not add those two exponents. Why? Because the bases are not the same. So that is going to be our final answer there. Now, the next question here says simplify the following again without the use of a calculator. Now we have 5 exponent 5 divided by 3 multiplied by 5 exponent 2. Now remember, when we are multiplying and dividing, we are looking for the same base. So we are going to look for the same bases here. Now look at that 3 there, and as we can see, that 3 has no another base that is the same as it. Well, firstly, there is an exponent 1 there, as we can see, but it is in the denominator. And when we look at the numerator, it does not have a power that has the same base as it. So it is going to remain as a denominator 3 as it is. Now look at that base 5. Now that base 5 has a exponent 5 at the numerator, and at the denominator we have another base 5 that has an exponent 2. So what is going to happen there? We are going to say it is that 5, and then we are going to say 5 minus that 2 over there. So what is our final answer going to be? Well, as the numerator, we have a base 5, and 5 minus a 2 is equals to 3. And as a denominator, we have that 3 over there. And that would be our final answer. Now, why are we not dividing these two powers here? Or why are we not subtracting the exponents of these two powers there? Well, of course, we are not going to subtract those exponents because the bases are not the same. So yes, it is division of powers, but the bases are not the same. Hence, that is going to be our answer over there. Then the next equation there, which is our last equation or our last expression, our last expression there, we have a exponent 4 multiplied by b squared multiplied by c, and that is all divided by a cubed multiplied by b. Now, what are we looking for? We are looking for bases that are the same. So we are going to look for bases that are the same. We have a base a there and a base a there. So that means that we are going to say there that it is a, and we have a 4 minus a 3. Then that is being multiplied by a b, and we look at the base b there, it has an exponent 2, and that base b there, the numerator, has an exponent 1. So that is going to be our exponent 2 minus 1. And lastly, we just have the c there. In the numerator, if we look at the denominator, we do not have another variable c. So how are we going to calculate that? That is a exponent 4 minus 3, that is going to be a exponent 1. And then we have b exponent 2 minus 1, that is going to be exponent 1. And then lastly, we have that c there. We also know it is an exponent 1. So what is our actual final answer? That is a multiplied by b, and that is multiplied by our c. And of course, why are we not multiplying or adding the bases of these three variables? Because the bases are not the same. Sorry, why are we not adding the exponents of these three bases? Because the bases are not the same. So that will be our final answer there. Let's quickly go to an ad break, and then we'll see you just now.